This year, the chassis was the main focus of our building. I wanted to make sure it was really stable this year because last year it was not very stable. We used mainly parts from last year's game, specifically the mount to form the chassis. And as you can see, the wheels are protected with these churros from last year's game and the mountain divider thing from last year. And the wheels are omnidirectional. They're mechanicals. They let us go in every single direction for their ball picking up and picking.
Our track is made of last year's mountain and one rail is 3D printed. Our intake consists of a series of zip ties that bring the ball up onto the track, which will be brought to the piston to be shot.
Alright, so for our shooter this year, we went on many designs. Started with a catapult, then went to a pitching machine, until we came up with the final design and called it a piston. The original one looked something like this, really big, too bulky for our use. So we did a lot of prototypes, came up with a design. It's only about 6 inches wide and long. It really worked a lot better. It's really compact sitting inside of the robot. It works really well. Unfortunately, the rack pinion didn't work too well, so we printed our own 3D gear, such as this one. And it works really well, just slipping right on the motor to pull back a lot of power and force to shoot balls in autonomous and air traffic control.
On this year's robot, we used a lot of the parts from last year's mountain to bring the wiffle balls from our intake system to our piston. And learning to create these custom parts in PTC Creo was a great experience that I know I can use later in life.
So our main point for the autonomous is the button pusher, which utilizes an attribute color sensor to detect the color of the beacon. We also have it running along a conveyor belt that is powered by another servo, which allows it to run across the beacon so we can look at both colors and determine which one we're pushing. Now, last competition we used the button pusher, it was on the same level as always. So we would constantly have to push to try and get the beacon. But now we've added another servo so that our button pusher can elevate or lower itself so that we can find the maximum angles for the biggest amount of points. And beacons are, even though they're only worth 10 points in the teleop area, that's still a 28 points swing either way, so that's a major contribution to our main selling points.
This year with our programming, we tried to simplify the code so that if anyone who does not know Robot C or knows nothing about code, they can come and look at our code and they can understand what's happening at each stage of the code. Also, we use a lot of methods, and in doing this, I learned a lot of how really I understood Robot C, as well as I got to learn some things that were going to help me later in life.
Here at Jesuit, we were one of the founding members of FTC in Louisiana, and because of that, we really like to spread FTC not only in the robotics community, but also in the community surrounding Jesuit. We really like to inspire teams that are coming from FLL to FTC, and we really think it's an important part of high school life and really helps someone learn not only organization, but also be part of a team. We really like the FTC program, and we really like to spread it. We've gone to other schools and help them out. We go to things like two-lane engineering and learn anything we can from them and then spread that to other teams. And then we also like to give out in the community with things like Hams for Fans and MLK on and off day. And for all these things, we really like FTC, we really like spreading our community.
This year, building the elevator for the catball objective was a really good learning experience. I learned a lot about linear dynamic motion and forklift properties. It's going to help a lot in the long run because a lot of things use linear dynamics, and it was implemented all across the elevator. In the stages, the pulling of the string, the bracing, so all